We're going to talk about how to do percent change and percent error. So I'm going to change this over here to percent change. So basically when it comes to percent change, what we're looking for is we're going to basically just take the change and we're going to use that as the part. And then the original is going to be the whole thing. And then we're going to use that to find the percent. So change over original. So if we're looking at this situation here, we have the original cost there is $13.43. The final price is $75.22. So the change just involves subtraction. So we're just going to take the bigger number, subtract the smaller number, and then we'll get that difference. We'll get that change here. So $13.43 minus $725.22. And that gives us a change of $617.78. And then to get our percent change, all we need to do is take that change out of the original to get the percent. So we can do this either as a proportion, or we can do this by simply just dividing part divided by whole. So the whole thing is 1343. So when we have a fraction and want to make it into a decimal, we just simply divide the top by the bottom. So we take that, our answer here is 617.78. And we divide that by the original. And that will give us a decimal. So 0.46, which is 46 hundredths, which means that's 46%. When we do percent change, we also talk about, is it increasing or is it decreasing? If it is a discount here and we're starting at 1343 and becoming 725, that means it's a decrease. So 46% decrease for going down, which makes sense because it is a discount. And there's our change. All right, let's find another one here. Let's just do one that isn't a context. So just between these two numbers, so from 14 to 38.64. Again, we're just going to change over original to figure out our percent change. So our change is going to just involve, again, subtraction. And I always just subtract the bigger minus the smaller one. Otherwise, we're going to have some negatives. And really just don't need negatives. So we're going to do 38.64. And we're going to minus the $14. And that will give us the change here, 24.64. That's how much it's changing by. And then we're going to make a percent out of that by doing the change out of the original. So the original, it says from 14. So that's where we're starting. That's our original. So out of 14 would be the whole thing, and this is the part. Again, to make a fraction into a percent, we could just divide the change, the top number, divided by the bottom number, and that will give us a decimal. And then we are going to do times 100 to get our percent. Oops, I did that a little wrong here. So that's how we do times 100. So this would be 176%. Let's go back to it. If it goes from 14 to 38.64, that means it's increasing. So 176% increase. That's how we do percent change. Percent error is actually kind of similar. It involves a change. The only difference is we're going to be looking for the amount that it changes by divided by the actual amount. So it looks very similar, but for percent error, it's the error, which is, again, just the difference, divided by the actual for our part over whole relationship. So if we're looking at this one here, it measures the volume to be 590. The actual volume is that. So to get the error, it's really just the difference. Just like it was for percent change, we're just going to subtract them. So we're going to subtract the bigger minus the smaller. Again, because we don't really need to worry about negatives. We just want the absolute value amount. So 590 minus the 365.8. That means they were off by 224.2. That's the error. And then to get our percent, we're going to use that error out of the actual. So 224.2 divided by the actual amount, which could be either one. So we have to read carefully here. It says the actual amount is the 365.8. So we got to make sure we use that number. 224.2 divided by 365.8. And it gets a decimal here, which doesn't mean we're wrong. We just need to read our directions and see how to round it. So 0.61290, etc. It says to round to the nearest percent. That's nearest whole percent. So as a percent, this would be 61.290%. So nearest whole percent would be about 61% error. Let's do one more percent error here. Let's do, I don't know, how about a concert? Here we go. Again, we're going to do what is the error, how much were they wrong by, divided by the actual amount. So the error, we're going to just subtract 230 minus 140, and that will give us how much they're wrong by. So 230 minus 140 is 90. That's the error. We go back and we see, think of it again as part of our whole relationship. So it's a 90 is the error out of the actual number, which is 140, and that will give us our answer. So 90 out of 140 is, let's see, so we'll call that 0.642857. So that's about 64.2857, etc. percent. And let's go back to the rounding. It says to the nearest percent, so that would be 64% error. We could also look at, besides finding the percent error, like all these are finding the percent error, we could also look at a different example. Like what if, for example, I say that, okay, she estimates that it's $175. That's her estimate. Or actually, let's make that the actual amount. I'm going to ignore this problem off to the left here. Suppose we have the actual amount, and we want to get some wrong errors. So that would be a different way to handle this percent error. So what if the actual, so new problem, what if the actual was 175, and then someone was off by, let's say, I don't know, how about 22% error? So what this means is there's actually two possible answers. This person can be 22% above or 22% below the actual numbers. So let me actually bring that back. I don't think I can bring that back easily here. Let's see. Here we go. So I want to take my calculator, and I'm going to do the 175 times 22%, which is 0.22. If you don't know that, take your 22% out of 100 to get your decimal. And then I'm going to find what 22% of 75 is, and that's, oops, I messed up. Hold on a second. 0.22. So that's 38.5. So that represents 22% of it. So if I'm trying to figure out what the errors would be, so 22% is 38.5. That's how much we're off by. So you could either add that or subtract it to get two possible errors. So you would do 175 plus 38.5, and then 175 minus 38.5, and that would be your two possible errors they could have made by estimating this. So I'm just going to do that here. So 175 plus 38.5, and then 175 minus 38.5. So 213.5 and 136.5. 213.5 and 136.5. So this might be a problem that comes up where it actually gives you the actual amount, and it says, okay, if they're off by 22%, what are the possible wrong answers? There's always two possible wrong answers, a bigger one or a smaller one. So we can do that as well as taking the actual and error and finding the percent error.